Imagine a world where the heavens were a divine tapestry, painted by God, unchanging and perfect. For centuries, this was the accepted truth, a cosmic order unquestioned, a celestial clockwork wound by a divine hand. But in the tumultuous 17th century, a thirst for empirical knowledge began to stir. A man with an insatiable curiosity, Giovanni Domenico Cassini, dared to look closer at this divine canvas, armed with a new, powerful, and still somewhat mysterious tool, the refracting telescope, a marvel of emergent optics and grinding precision. Giovanni Cassini wasn't content with inherited wisdom, the pronouncements of ancient philosophers like Aristotle, or the dictates of religious doctrine that placed Earth at the unmoving center of creation. He believed, with a conviction that would define his life's work, that the universe, however grand and awe-inspiring, followed predictable, measurable rules. He dedicated himself to the arduous, often lonely task of meticulous observation, recording every flicker, every subtle shift in the celestial dance with an unwavering patience that bordered on the obsessive. His eyes, honed by thousands of hours dedicated to peering into the infinite dark, began to discern details that remained invisible to others, or perhaps, were deliberately ignored by those bound by tradition. Through the polished lenses of his increasingly sophisticated instruments, the distant planets began to yield their secrets, not as mere points of light, but as worlds. He charted the course and surface features of Mars with a detail never before imagined, capturing its ruddy hues and perceived landmasses with unprecedented clarity, a vibrant crimson orb against the velvet black. But it was Saturn, that majestic, enigmatic giant, that truly captivated his scientific soul, a world already known for its strange, ringed appearance. This distant, luminous jewel of our solar system held more than just visual splendor. Cassini's painstaking observations, extended over many nights from his observatory in Bologna, and later in Paris, hinted at something extraordinary, something profoundly unexpected: moons, small celestial bodies, orbiting this colossal planet, a miniature solar system in itself. He identified not one, not two, but 4 of Saturn's moons, bodies that had escaped all previous notice, lost in the planet's overwhelming glare. These were the moons that would later be named Janus, Mimas, Tethys, and Rhea. This was a monumental claim, suggesting a complexity to our solar system that directly challenged the prevailing cosmological models, the tidy, Earth-centric universe of Ptolemy. It implied a universe far more intricate and dynamic than previously accepted, shaking the very foundations of astronomical understanding with its audacity. The established scientific community, deeply entrenched in centuries of Aristotelian physics and Ptolemaic cosmology, and now grappling with the heliocentric ideas of Copernicus and Galileo, reacted with predictable shock and profound disbelief. How could mere mortals presume to unravel such divine mysteries, to quantify the immutable heavens? Cassini's claims were swiftly dismissed as mere optical illusions, the product of an overactive imagination fueled by too much wine, or, more damningly, evidence of outright madness, a dangerous departure from established truth. They called him a lunatic. His groundbreaking discoveries, meticulously documented in his meticulous logs and supported by his irrefutable observations, were deemed preposterous flights of fancy, his painstaking work, a foolish waste of precious time and resources. The celestial sphere, they vehemently argued, was the exclusive domain of God, not a playground for human measurement, relentless speculation, and empirical inquiry that dared to contradict established dogma. His reputation, he knew, was being systematically dismantled by whispers and accusations. But Giovanni Cassini, though perhaps disheartened by the rejection and the personal attacks, was not deterred. He knew the truth lay not in the pronouncements from theological or academic pulpits, but in the cold, hard data gathered by patient, unbiased observation. The universe operated on immutable physical principles, laws that governed the motion of stars and planets alike, and he was slowly, painstakingly, uncovering them, one precise observation at a time, a testament to the power of empirical evidence. He continued to refine his measurements, to meticulously cross-reference his findings with every available piece of data, to calibrate his instruments with obsessive care. He understood that scientific truth, unlike rigid dogma, could withstand rigorous scrutiny and repeated testing. It demanded precision, careful calibration, and an unwavering commitment to what his eyes and his instruments unequivocally revealed, regardless of the prevailing consensus or the comfort of established theories. His dedicated work on Saturn yielded another remarkable, unexpected insight that would etch his name into the celestial map forever. While observing the planet's prominent, luminous rings, he noticed a distinct, dark line dividing the bright bands of ice and rock, a clear separation that seemed impossible by the understanding of the time. This division, a clear separation within the rings, is now famously named the Cassini division, a key structural characteristic of Saturn's majestic rings and a testament to his sharp vision. This discovery was profoundly significant. It demonstrated that Saturn's rings were not solid, monolithic structures, but composed of countless individual particles, each in its own orbit, a concept far ahead of its time. It suggested a dynamic, granular nature to the cosmos, a departure from the smooth, perfect spheres often imagined. The Cassini division was not an illusion, it was a physical reality, a testament to the complex architecture of the solar system that Cassini was slowly unveiling. The scientific establishment remained largely unconvinced, their minds closed to these revolutionary ideas. It was easier to dismiss Cassini's findings as errors of observation, as phantoms conjured by his telescope, than to fundamentally alter their understanding of the universe. The weight of tradition and the fear of challenging established dogma proved to be a formidable barrier, even in the face of compelling evidence. Yet, Cassini persevered. He was appointed director of the Paris Observatory by King Louis XIV in 1669, a position of great prestige that allowed him to continue his research with greater resources and influence. This move to France, a hub of scientific innovation, provided him with the opportunity to further validate his discoveries and to continue his relentless exploration of the heavens, slowly but surely building a body of evidence that could no longer be ignored. He didn't just observe, he measured. Cassini applied rigorous mathematical principles to his celestial observations, calculating orbital periods, distances, and the sizes of planets with unprecedented accuracy. He pioneered the use of micrometers, specialized instruments attached to telescopes, to precisely measure angular distances between celestial bodies. This quantitative approach was revolutionary, moving astronomy from a descriptive art to a precise science. His work on determining the scale of the solar system was groundbreaking. By meticulously observing transits of Mercury and Venus across the face of the Sun from different locations on Earth, he was able to use parallax, the apparent shift in an object's position when viewed from different angles, to calculate the distance to these planets. This was a monumental feat, providing the first reliable estimates for the size of the solar system. He calculated the Earth's diameter to be approximately 12,700 kilometers, remarkably close to the modern accepted value of about 12,742 kilometers. This was achieved through his precise measurements of the Earth's shadow during lunar eclipses and his triangulation techniques. He was essentially measuring our own planet with the same tools he used to explore the cosmos, linking the terrestrial and the celestial in a profound way. His contributions extended beyond Saturn and Mars. He meticulously mapped the surface of the Moon, identifying craters, mountains, and valleys, creating the most accurate lunar map of his time. He even proposed that the Moon rotated on its axis, a concept that would lead to the understanding of synchronous rotation, where a celestial body's rotation period matches its orbital period. Cassini also studied comets, recognizing that they were celestial bodies following predictable orbits, much like planets. He correctly deduced that the comet of 1680, which appeared spectacularly bright and passed very close to the Sun, was a single object on a long, elliptical path. This understanding paved the way for later discoveries, such as Edmund Halley's prediction of his famous comet's return. Despite his growing list of undeniable achievements and his prestigious position in Paris, the whispers of skepticism and doubt never entirely faded. The scientific community, while slowly beginning to accept some of his findings, still struggled with the radical implications of his work. The idea of a universe teeming with previously unseen moons, of rings composed of countless particles, was simply too far removed from their established worldview. One of the most persistent criticisms revolved around his observations of Saturn's moons. Some argued that his instruments were not powerful enough to resolve such small, distant objects, and that what he saw were merely imperfections in the telescope's lenses or atmospheric distortions. The idea that he could see these tiny specks of light orbiting a planet millions of kilometers away was, to many, simply beyond belief, a phantom of the optical glass. He was also accused of sometimes fabricating data to fit his theories, a grave charge in the scientific world. This often stemmed from his attempts to create a unified model of the solar system, trying to reconcile his observations with the existing mathematical frameworks, even when the data didn't perfectly align. This desire for a cohesive, ordered universe sometimes led him to make estimations that others deemed speculative. The very precision that made Cassini's work so revolutionary also made it vulnerable to criticism. His detailed measurements, when compared to the less precise observations of others, often revealed discrepancies that fueled skepticism. Instead of acknowledging the advancement in observational technology, many clung to the idea that Cassini was simply wrong, his enhanced vision a source of error rather than insight. The philosophical implications of his discoveries were also unsettling. If the heavens were not perfect and immutable, if they contained vast, empty spaces and complex orbital systems, what did that mean for humanity's place in the cosmos? It challenged the anthropocentric view of creation, suggesting a universe far grander and more indifferent than previously imagined. This existential unease contributed to the resistance he faced. Cassini's family also became deeply involved in astronomy, continuing his legacy. His son, Jacques Cassini, and grandson, César-François Cassini de Thury, both became accomplished astronomers and geographers, further solidifying the family's influence in the field. They meticulously updated and expanded upon Giovanni's star charts and astronomical tables, ensuring that his pioneering work would not be forgotten, but rather built upon by generations to come. The concept of scientific progress itself was still in its infancy. While the scientific revolution was underway, the idea that established knowledge could be completely overturned by new observations was not universally accepted. Cassini was a pioneer not just in astronomy, but in the very methodology of scientific inquiry, advocating for observation and measurement over tradition and authority, a difficult and often thankless task. His deep understanding of optics was crucial. He not only used telescopes but also improved their design, grinding lenses with greater precision to minimize aberrations and distortions. This mastery of optical principles allowed him to see further and clearer than his contemporaries, providing him with observational data that was simply unavailable to others, giving him a unique advantage in his quest for celestial truth. The story of Cassini is a profound exploration of the human condition when faced with the unknown. It speaks to the courage required to challenge deeply ingrained beliefs, the resilience needed to withstand ridicule and doubt, and the ultimate triumph of empirical evidence over prejudice. His life's work was a testament to the power of human curiosity to unravel the universe's deepest secrets. He lived to see many of his discoveries slowly gain acceptance, though the full impact of his work would only be appreciated by future generations. The Cassini division, the moons of Saturn, his precise measurements of the solar system, these were not mere observations, but fundamental shifts in our understanding of cosmic mechanics, echoes of a universe far more complex and beautiful than previously conceived. His legacy is etched not just in the names of celestial features, but in the very fabric of modern astronomy. He demonstrated that the universe was not a fixed, perfect creation, but a dynamic, evolving system governed by discoverable laws. His relentless pursuit of truth, his willingness to trust his observations over dogma, laid the groundwork for the scientific revolution and our continued exploration of the cosmos. Consider the courage it takes to stand alone, to see what others refuse to, and to speak truth to established power, even when it means being branded a lunatic. Cassini's life reminds us that the greatest discoveries often emerge from the deepest skepticism, not of the universe, but of our own limited understanding. He taught us to look, to measure, and to trust what we find. His story is a powerful testament to the scientific method itself, the unwavering commitment to observation, measurement, and logical deduction, even in the face of overwhelming opposition. He didn't just map the stars, he charted a new way of knowing, a path that continues to guide our quest for understanding the universe and our place within it, a legacy of intellectual bravery. So, the next time you look up at the night sky, remember Giovanni Cassini. Remember the man who saw more, who measured more, and who dared to believe his eyes and his calculations when the world told him he was mad. His work forever changed our perspective, revealing a universe far grander and more intricate than anyone had dared to imagine before his time. His discoveries, born from solitary nights and relentless effort, continue to resonate. They remind us that the universe holds infinite wonders, and that the greatest adventures are often found in the quiet, persistent pursuit of knowledge. The truth, however elusive, is always there, waiting for eyes willing to truly see it, and a mind brave enough to accept it, no matter the cost. Digging into the archives to uncover the precise measurements and the quiet courage behind Giovanni Cassini's story took weeks of sifting through brittle documents and cross-referencing obscure star charts. If his perseverance moved you, a like and a subscribe are how you ensure the next story no one else tells gets its chance to be heard.